Well, hello everyone, and thank you again for joining us today for a safety webinar covering choosing the best crane for your application, Workstation, overhead, and Jib Cranes. In this webinar, we will talk about the benefits and limitations of Workstation standard overhead cranes and Jib Cranes. We'll also discuss the best applications for each and how they can help you lift and position materials as safely and effectively as possible. My name is Gisela Clark. I'm the e-marketing specialist at Columbus McKinnon and will be your host for today's webinar. Presenting today is Tony Alessi. He's our marketing manager for Unified Industries, a Columbus McKinnon company. Tony's been with Unified for 6 years and has worked within the automotive industry for the last 16 years. We are recording the session today, and the recording link will be added to our YouTube channel, as I mentioned earlier. All in attendance will receive a link to the recording. Everyone is in listen-only mode, so we encourage you to ask questions in the Q&A pane on the right side of your page. We'll take 5 minutes at the end, and as I said, we will stay on as long as needed to make sure everyone's questions get answered. As a side note, after each webinar, we select one of the questions to be used in our blog the following week. We have a blog with pretty close to about 200 articles that we publish about once a week, going back many years already, with all kinds of content on a variety of different subjects. And we love to feature questions after each webinar. So if your question is chosen, we'll send you a nice CMCO promotional item, something like a polo shirt, hat, work gloves. Now that golf season is heading in, I even have a set of golf balls I could send. So send us your questions. I'd love to post you on our blog with your question and answer and send you something fun. So I appreciate your attention today, and now I will turn the meeting over to Tony so that we can begin. Tony?
Thank you very much, Gisela. Good morning, everybody. Like she said, my name's Tony. I work at Unified Industries doing the marketing. Today's topics, we're going to be going over the benefits, the limitations of the systems, the best applications, and how to make cranes actually, work for you and be a safe alternative to handling it by yourself. So let's start off today when we're going to talk about the use of overhead lifting versus manual lifting. These are some good pointers for when you want to use something more than just the manual person actually lifting it. So if the load weighs more than 35 pounds, that's something you may want to consider an overhead lifting application. If the loads, if the worker is extending their hands or bending over a lot, that's another application where it would require possibly overhead handling and possibly a lift assist as well. Repetition, so multiple times per hour. Here in Detroit, we're located in Howell, Michigan. We have mostly an automotive base, and some of the tack times for an application is 70 times an hour. So things like that, that's what you'd like to have an assist of some sort helping you with the process. When the load's transported at a long distance, something more than 20 feet, that's another red flag where you'd probably want to use an overhead lifting application. When more than one person is moving it, and then also when the floor space is limited, so you may have conveyors, you may have high-lows coming in and out of the area, something to take away from person moving potential hazard. Some general safety guidelines I'd like to just go over real quick. Make sure the system that you purchase is ANSI certified. Obviously, CES, Able Howell, and Unified Design Structures that are ANSI certified. Make sure the system's installed by a qualified installer. That's very important. I've seen people, hire somebody down the street that's not qualified, and obviously it can lead to a lot of safety issues. Do not lift more than the posted rated load of the system. So make sure when you purchase a system, you account for everything in the application and the process. Make sure it's not used to lift or support people unless it's designed for that purpose. A side note to that, Unified Industries is coming out with a fall protection system, which would be able to use in that purpose, and you should see something shortly in the next month or so for that. Make sure it's inspected and you follow all the manufacturer's recommendations. Again, the Columbus McKinnon companies, we all have all that information on our website, and you receive that when you purchase the system. So let's start talking about ceiling mounted bridge cranes and runway systems. So commonly, this, at least in our business, this is the most common setup that we use. I would say 70% of the systems that we sell are overhung systems. Here's some of the guidelines. So if the building steel is able to support the weight of the system, that's when you could use one of these systems. We typically see, like, again, being from the more northern part of the states, that buildings are designed with heavier, steel structures to support like the weight of snow, stuff like that. We've seen sometimes down south, a lot of the buildings maybe don't account for a snow load, is what it's called. So you'd want to make sure you check with the facility in question, and they usually have drawings, or the facilities engineer would provide you with something to, to prove out that an overhung system would be safe. Another reason why you use an overhead system would be if the production floor needs to be free from columns. So again, if you have a lot of high-lows coming in and out of there, it's less of a chance for them to, hit something. If your rail system can connect to the building steel at a reasonable height. So another issue we come across is if your building has, 30-foot ceiling height, and you need to, work at a 12-foot underclearance from the bottom of the bridge, sometimes this may not be the best, fiscally responsible way to solve your handling issue. You may have to, bring down a bunch of steel to get down to that point, and it just may not be a cost-effective solution. So make sure it's at a reasonable height. Hanger spans at reasonable lengths. So what that means is, you have to connect your system using hangers to the overhead steel. And if your steel's spread at like, 30 or 40 feet, sometimes, for us to come across for that, it may just not be another cost-effective solution. You may have to look at a different option. And then the future possibility of making changes to the system. So if it's hung up on the overhead rail, the steel beams, it's a lot easier to, add pieces, take out pieces, more than if it was another, like a floor supported structure, which we'll talk about in a little bit. This here is a typical rail system layout. So you can see that you have your overhead building steel. I'm not sure if my cursor shows up here, but
it does.
This could, oh, it does, great.
Yes.
So this would be your overhead building steel, and then this would also account for a monorail system as well. So a bridge and a runway system, obviously the runways run below the steel, and then the bridge runs perpendicular to the runways. The objective, obviously, is to determine the most optimal method for picking up and transporting the product in a given work area, and obviously the safest way is what is most important. Rail systems are made up of 7 basic components. So like I mentioned, the runway, the bridge, but then there's also the hangers which connect to the steel. The end trucks, if nobody's familiar with what an end truck is, it's what connects the runway to the bridge. There's trolleys, which you hang a hoist from, or a lift assist. End stops, which obviously need to be prevent you from having the bridge come off. And then festoonings, and again, for those who don't know what festooning is, it's almost the power source to the unit that's being used. So if it was a lift assist that used air, you'd have an air line or an air hoist, and then also you have the electric versions too. Stack up. So the reason why this graphic's on here is sometimes your stack up is basically from the steel down to the bottom of the bridge, or the hoist hook. It depends on what you're trying to grab. But sometimes if the stack up's too high or too low, it depends on you don't want to have too long of a steel. I've seen companies that use large threaded rotted hangers, or we can use drop angles. But at a certain point, you may want to use a different option. And the other option, if you're looking for a bridge and a runway system, would be the freestand structure. So as you can see, these are a couple different versions of freestand structures. When we're going to use these now are when the building steel is unable to support the weight of the system. So you wouldn't have strong steel up there. You'd consult with your facilities engineer. This would be a time where you want to consider a freestand structure. when the rail system's unable to connect to the building steel at a reasonable height. So again, you have a 30-foot structure, you only need to be 8 foot below the bridge. Probably this would be your better option. Again, the hangers, so is pretty much the opposite of what, an overhung structure would be. So if your hanger spans are just too long, as you can see in some of these structures, you can put hangers wherever you want. So it would be cheaper to purchase a hanger than it would be to buy a bigger piece of steel to reach the span needed to connect to the two. Here's another one too. When the system footprint is not expected to change, so well, that would mean, if you're planning on changing your process and you want to move these columns, obviously it's more difficult to move and to add and subtract pieces of rail or adding bridges when it's already in place. I've seen times too where you put up a structure and then they put a conveyor through it, and somewhere where the conveyor turns would be where a structure would be. So obviously we'd have to redesign the entire freestand structure. So make sure before you do a freestand structure, you're pretty sure that where the footprints go, the columns footprints, they wouldn't change. Another benefit though of a freestand structure is, this is something that could be moved. So if you change your process and move it to the corner of your building instead of, its current location, it's not that difficult to take apart, put away or move.
Tony,
another thing that can,
oh, sorry,
yes, go ahead.
No, please,
Nope.
go ahead.
One more thing I want to point out too. Another thing to consider is freestand structures can, you can move them around. They're just one thing to consider though is we see this, say you have a system that's 500 pounds, and make sure these systems are all custom designed. So make sure, if you're going to purchase a system, another thing, if you think your process will change and maybe the next model year of a car, for example, or whatever would go up, make sure you kind of design your system maybe a little more than what you need if you think it's going to change. That way, you can still use it if, a part weighs another 500 pounds in the future, So that's just another thing to think about.
That's a good point because, like you said, you want to make it versatile because things are always seem to be changing. But I have a question for you on this. What is your general specification and how you anchor freestanding structures?
Sure. Yeah. What we do is, for most structures, we recommend a 6-foot embedment with 3,000 psi reinforced concrete. Typically, we use wedge anchors or the adhesive anchors. So I assume most people know what those are, but if you don't, the wedge anchor would kind of be like almost a wall anchor that you see in drywall where you'd screw it in the ground, and then when you tighten it, there's two side pieces that wedge it into the ground. The adhesive anchor, you drill a hole again, but you basically put in like a liquid adhesive, like a concrete adhesive, put the screw in, bolt it down, and then it hardens, and then it's permanently in the ground. So.
Okay, thank you.
I do want to talk about a basic freestand system design. Again, some of you, I'm not sure of everyone's background, but some of you probably know what this is and some of you don't. I know when I came to Unified, I didn't really know much about these, a while ago. And, just this basic drawing really cleared it up for me, so I'm sharing it with you today. But your basic freestands are, when someone says it's the header is typically running parallel with the bridge. So these are the steel beams that hold up the system. Most freestand structures, and again, not all, are usually 4 to 6 columns. We've done 8, we've done 10, we've done 16, but I would say the vast majority of them would be 4 to 6 columns. That seems to be the most common type. This is called the stringer. The stringer runs typically parallel with the runways. And then the runway rail, which we learned before in the last couple slides back, runs with the stringer. We also have, obviously, the columns. Typically, when we build structures, they're 12-foot underclearance. I would say that's kind of the most common one. When you're trying to decide what system to use, obviously the lowest you can go to the application is the most effective. It's the easiest for operators to move. when you have something way up high, like 20 feet in the air, and you don't need it, you're basically, you're still pulling the bridge. It obviously would be in your best interest to use something very close to the ground. Choosing your freestand system. So we have many different types of freestand systems, or there are many out there. The first one you can see here is the standard system. So it's kind of like what I showed you on the last slide. This is kind of like it has its own skeleton of steel. So you have your stringers, your headers. These are the systems like, if you require a PE certification, this is one you'd purchase. Something in a seismic zone. For unified purposes and CMs, this is the kind of system you use for between 1 to 2 tons. Right below that, you'll see we have a light-duty version, or there are light-duty systems out there. These, I would say, would be up to 1 ton. This would be the most cost-effective option to use. And you can see the difference between the two, that the stringer, the steel above it on the standard structure, is gone on this one. So we're just going to use column, header, and then the runway connects to these two. So obviously, these are a lot cheaper. You wouldn't be paying for that extra steel. However, you'd lose, like a PE certification or in a seismic zone that probably, may not be what the professional engineer would prefer. You can also see for systems above 2 tons, this would be a more fully enclosed heavy-duty structure with a top running crane on it and a wire rope hoist. These are kits available as well. Another version that we kind of sell a lot of is called a hangman or a lamppost style. Now these are interesting because you can, let's say for example, you have on one side of a conveyor, a lot of either columns from the big building or traffic with, high-lows and trolley carts pulling product around. This would be able to mount on one side of the rail, and obviously with those gussets you can see are reinforced very well to support an entire system. The graphic I'm showing you right now just has 2, but we've done them where these lamppost structures here would run all the way down, even 20 long, and it would run a monorail or a bridge in this version. This would be a runway right here, and then the bridge is looking at us. That little red dot would be the end stop. So you can, we can custom make any kind of system, that you need. Hold on, it's freezing up here. There we go. So just so you know, we were talking about overhung systems with bridges and runways. So that would also include just a regular old monorail system, and a monorail would just be a piece of rail where you'd have weld guns riding up and down the process or the assembly line. Both systems, the overhung system as well as the freestand system, could also support any of these kind of common bridge configurations. So, a single bridge, this would be an example of a dual bridge. So a reason why you'd use a dual bridge would be if you had, a lift assist in the middle with a carriage. We also can offer, both systems can support a low headroom end truck with a bridge. So that would keep your bridge at the same level as the runways and obviously give you less of a stack up. I know a lot of you who sell the hoist would know about hook height and trying to maximize your stack up. The dual end truck would just be for more weight. Another thing that we sell a lot of, this would be an example of the bridge that rides on steel. So these end trucks right here would ride on steel. So people like Caterpillar, John Deere, who have a lot of patent track or S-beam track for a runway, now you can incorporate a bridge on their overhung system, or we could design a freestand system that would still incorporate the steel, but then the bridge would be an aluminum bridge. Another concept that we sell is a tri-bridge. So this would be 3 runways. Sorry, get my mouse here. This would be 3 runways over the bridge. So that's another thing we can do. If you ever hear the term capping rail, so this is something we offer here. If your spans are long, like we talked about with the overhung structure, where you do have to, span over a large distance before you can hit another hanger for a runway system. We can offer a reinforcement that goes above the rail, and it increases the lift capacity and the of the rail systems. So we offer that as well in case you do need to do an overhung system. This is when you'd use capping. There's other things too if you're doing an overhung system and you have to have a long system, or for example, if you're in like a room and you need to maximize the entire room to get the bridges on or off, or even trolleys within it, you'd have to take off the end caps. And if you don't really have much room, how would you get the bridge on or off? So both our overhung systems and for freestand systems, you can use an inspection gate. So what this is a trap door, people call it, or it flips up, it's welded on, flips up, and then you can remove and add and remove products. So that's something that you can use for both versions. You can also use curves. So if you need to use an overhung system and have a curve, that works. And it would also, we've done curves on freestand systems too. So if any of your applications like we talked about earlier require a curve, that option's available. Here's another thing that people use a lot too. So say you did set up your overhung system, but you do have building pillars in the way of perhaps a reach point where you'd have to pick something up. Both systems we can do telescoping rail, so that's when you'd use a telescope rail for an overhung or a application with a freestand structure. Now I'd like to talk about jib cranes. So jib cranes, provide an important part of your process. They're the cheapest, the most simple option. Some big things you wanted to keep in mind though when you use a jib crane. They're good more for low duty cycles. So 70 times an hour, I probably wouldn't recommend that you'd spec out a jib crane. It's more for a dedicated individual workstation to suspend tools. So like a light Packers Chromer spring balancer with a nut runner on the end, something like that. That's the optimal time to use a jib, or to change out a die, something that doesn't require so much use. One of the biggest reasons is obviously it makes a circle, so it's not an XY square or a rectangle like a overhung system or a freestand system. You do need to also make sure that when whatever your process is, that you work more from the furthest from the mast. The closer you get to the column of the jib, the harder it is to move. So that's another thing to keep in mind. Also with jibs, depending on the weights, we offer jibs up to 10 tons, even more. You need to keep in mind the base plate size. So obviously, you could have a base plate that's 4 foot square, so that would take up some of your shop floor. Also the concrete depth. So when you start to get into those higher ranges, you'd have to pour your own foundation slab that could go 6 feet deep by 8 foot square. So keep that in mind. Also, there's different jibs for different applications. Some go 360 degrees, some go 220 degrees. Here are some types of jib cranes that you can use. You have a base mount type. This would be your most common. This would also travel 360 degrees, and it would be more for, this would maximize your underclearance because it's like a low profile. There's also a foundation mount jib. So this would be one that you'd actually dig a giant hole in the concrete, pour it, fill it, probably 6 feet deep, and it would be permanently there. Obviously the base mount one could be moved. This is a type, there are two types of wall mount jibs. This would be the same kind of thing, a low profile one. This would be where you need to maximize your headroom for your application. We also do a wall mount tie rod. So obviously if you don't have a ceiling restriction or an overall height restriction, the wall mount tie rod would be your best, cheapest option. We also are coming out with a lightweight 360 base mount. So this would be up to, I think, 1,000 pounds. So these would be from your more, like I said, the Packers Chromer versions, stuff like that. And then this is another common one, a tie rod base mount. So obviously pros and cons. The cons of this one would be if you have an overall height restriction, you wouldn't get as much under clearance, so you'd probably want to go with this option. So just an overview, features and benefits of all these systems. The CM product line, for Unified, we use, Almag, alloy castings, double bearings. The purpose is to minimize, injuries, maximize safety, and make it easy to use so your workers do not, get injured, less downtime. Safety, everything has a dual redundant safety for all the critical components. Everything's tested to 5-to-1 yield stress. So what that means is an ultimate stress would be, if something's rated for 500 or 1,000 pounds, ultimate stress test would be 5,000 pounds. It breaks, but it doesn't even bend any of our products that are all independently tested. It just, the yield, there would be some deformation at 5 times. So everything's a lot, designed for more safety thoughts. High production movement, I mentioned this earlier, a lot of these things are designed for more like 70 times an hour, more than, once a week. I did mention that, these profiles are aluminum, but then also we offer obviously all steel as well. Quoting information, these are going to be available, and Gisela will give you the links for them. But if you are specifying a system, we do have questionnaires set up in a PDF that's editable that you can, feel free to use and work on. Some of the big questions, obviously, we would need to know the rated load of the system, what's the total length of the runway you need, bridge information. There's a question about cantilevered load, and what that is if you have perhaps like an articulating arm reaching outside of the system, we would need to know, how long the arm is, what's the weight of the arm, what's the weight of the product you're lifting, because obviously that creates forces on the freestand structure or the overhung system. We talked real briefly about the bridges. You saw there's a dual bridge, a single bridge. Some people always question what's the CTC, so that's the center-to-center difference between the bridges. So most commonly you'd find it'd be 24 inches or 36 inches. What's the underclearance needed from the bottom of the bridge? That's obviously a big one. Some more, questions. You need the air electric festooning. If you do require a freestand structure, the PE cert, which state? That's another thing that's kind of important. For example, like in California, if you tell us it's going to California, they're specific as they want to know the address of the structure. There's, just to find the correct seismic zones. They have a more extensive package with calculations that the state requires. So make sure if you do require a PE cert, a lot of people are going to ask, what state is it in? What country is it in? Canada has different requirements. Mexico has different requirements.
Tony, on that point, do we offer PE certification?
Yes. Yep. You just need to let us know, and we can quote that for you.
Perfect. Thanks.
Another important question that you need to consider when you're quoting an overhung system is this would be only for overhung. So it says, how does the structural steel run in regard to the runway section? So what that means is if you look up in one of your buildings, you obviously have big, steels running. So if the runway runs that you want to place runs parallel with the steel, when you're quoting a system or when you're inquiring about a system, that would be that's the easiest way to hang a system, because your limitation is always the deflection in the rail or the sag in the rail between the two hang points. So if you can put hangers closer together, you can hold more weight. So the reason why we ask that question is because if it's running parallel, this is the overhead steel running parallel to the runway, it's the best case scenario because you can add more hangers. If it's perpendicular, this is where, like I talked earlier, where you may need to require a freestand structure, because if they're spaced, 40 feet apart, the odds of hanging, how big the piece of steel would need to be to hang 40 feet apart to build a system, it may be just cheaper to use a freestand structure. Just so you know, we also have this on our Able How CES websites as well. So There's another form for top running cranes or underhung cranes. There's another inquiry form for the jib cranes. All these, we also have case studies available. So there's 4 made right now. We're continuously making more. Obviously, whoever's interested in or has a case study, we'd be really interested to hear from you about making one. Gisela, you have these available for them. Is that
Yes,
correct?
if anyone would like those, I have PDF files I can email you. So just respond to the webinar confirmation. Just shoot me a quick message, and I'll be glad to stick those 4 in an email to you. And as Tony said, I'll also in the follow-up email with the recording link, I'll include links to those 3 forms. I think a lot of times in all the stuff that we're talking about, the questions are so important up front so that you really can best specify. So we can make those available to you so you have everything you need to. And I'm sure you're very familiar with it, but in case you're not, we'll provide links to those as well.
Great. And then also, speaking of links, this would be the links for the Unified website as well as the CES Abel Howell website. And obviously, if anybody has questions on, how to navigate through these sites, they're pretty easy, pretty self-explanatory. I actually did them both. So there's dimensional drawings available. There's PDFs, part breakouts. I've tried to make it very easy and simple where if you are in a plant and you need to order something or need to inquire some information, it's pretty quick to navigate through. So
Okay.
with that, does anybody have any questions?
Yes, a few questions have come in. I just want to clarify something. Back when you were talking about the freestanding structures, you were talking about needing, I think you said a 6-foot embedment. Is that correct? Or
6 inch. Yep.
I'm sorry. Okay. So for the freestanding system, it's 6 inches, but for the jib cranes, they would need a 6-foot. That's what you were saying.
Well, everything depends on the weight. So, for example, if everyone can still see this, the tie rod base mount right here, these are up to 2,000 pounds. So these would require probably, I think, up to the 2,000 pound model, maybe 8 to 10 inches of concrete.
Okay.
Okay. It depends. Everything's based on the weight. So like this base mount jib crane, for example, I mean, when you start getting up to 3 ton, 5 ton, so obviously the more weight, just like a tree, I guess, as how I always say it, the taller the tree, the bigger the roots.
Gotcha.
So, I mean, that's how it is here. So the more weight, it just depends. Exactly.
Yeah, okay. All right.
And by the way, all those, or Gisela, sorry, all that information and what the embedment requires is all available online on both the websites. So if you do have a question about that, you can look it up immediately.
Perfect. All right. Some more questions from Larry. What is a high-low?
A high-low? I'm trying to think. I've gotten this before because people are like, what's a high-low? Well, it's, the fork truck. I guess maybe it's a Michigan thing. We call them high-lows.
Oh, okay. A little bit of local flair there, Tony. Good. Okay, thanks for the question, Larry. A question from Brad. The lamppost design can support what maximum weight?
Well, actually, the lamppost designs are all custom made. So, I mean, I don't want to say, anything, but, anything is possible. The most commonly, we probably go up to 1 ton for those, but that's not to say we can't do more at all. So it would be just something you have to look at and, how we size it. We don't have any, off-the-shelf part numbers and kits for lamppost structures.
Okay. All right. So it's, okay, good. Excellent. Thanks for that. And this question comes from Nathan. On the freestanding unit, should you have them connected, welded to the sides of the building?
No. When they're designed, they're not designed to tie to building steel. I mean, if that's something that your plant requires, go ahead, but we don't recommend. I mean, it's not a requirement.
Okay.
Or a suggestion.
Perfect. Okay, that's all the questions we have for now. If you can go ahead and advance to the slide on the training, I just want to share a little bit in case anybody's interested. But we just always like to share some upcoming classes we have. If you're interested in more of the rigging or crane operator, we have a rigging and crane operator train the trainer workshop at our new facility, which we're still finalizing right now. We're physically in the new facility in Buffalo, but our training center will be ready shortly. But that will be in May. And we have an overhead crane and hoist inspection in Charlotte, North Carolina in May 10th through 12th, as well as a chain hoist technician certification class in April in Charlotte. That's where I'm located right now. We also have 2 new online classes for those that might want to be getting a recertification in chain hoist repair that now can be done in an online class. And lastly, we also have the overhead crane and hoist inspection recertification. So I just wanted to let you guys know about that. So as you know, you leave the webinar, you have any more questions, feel free to respond back to, again, the confirmation email to my email address, and I'll put you in contact with Tony so that you can get your questions answered. And Tony, if you can go to the last slide, please.
Sure.
Perfect. I just want to let you know we are very active on social media. If any of you are on Twitter or YouTube, as I said, we have all of our videos for our safety webinars there, along with many other training videos. You can find us there under Columbus McKinnon. We're very active on Facebook. We post a ton of application shots, links to our blog articles, invitations for webinars, and other things that we find that you share with us on social media. We have quite a following on LinkedIn as well, if that's where you're active. We also are on Google Plus and Instagram. And lastly, as I said earlier, we have a blog, and all those links you can find on our main webpage, which is at cmworks.com. So there are no more questions at this point, Tony. So again, if you have any, feel free to send them to us. And other than that, we thank you for joining us today and wish you a good rest of the week. Thank you, everyone.